So the main goal of section 1.6 is to talk about complex numbers, how to add them, subtract them, multiply, and divide them. Then we're going to talk about square roots of negative numbers and complex solutions of quadratic equations. So let's start out with the definition. Let's define a complex number. A complex number is an expression of the form a plus bi, where a and b are real numbers, and I squared is equal to -1. I squared is equal to what? -1. Good. You're going to use that a lot. I squared is -1. Okay? The real part of the complex number here is just a. The imaginary part is b. So the part that has an I is the imaginary part. The part that does not have an I is your real part. Two complex numbers are what we say equal if and only if their real parts are equal and their imaginary parts are equal. Okay? So examples of complex numbers: 7 plus 6i, 7, 8 minus 5i, and 3i. What's the real part of 7 plus 6i?
7.
What's the imaginary part?
6i.
Good. The 6. Good. So the real part was 7, the imaginary part was 6. What's the real part here? 7. What's the imaginary part? 0. Good, because there is no I part. So plus 0i. Here, what's the real part? 8. And the imaginary part? -5. Good. And then the real part here is 0, and the imaginary part is? Good. 3 is 3. Good. Okay. Arithmetic operations on complex numbers. So in order to add, subtract, multiply, this is what we do. Okay. To add two complex numbers, if you have a plus bi plus c plus di, that's a plus c plus b plus di. A plus bi minus c plus di is a minus c plus b minus di. So notice, distribute the negative and then rewrite it. Okay? To multiply two complex numbers, you have to use the FOIL method. So you would have a times c plus a times di. That's where this AD comes from. Then you would have plus BCI. So this is BCI. And then you would have BI times DI. And I'm going to show you here BI times DI is equal to BDI what? Squared. I squared is what? -1. So this is BD times -1 or negative BD. This is why you have minus BD here. Okay? That's why you have minus BD there. So we're going to express the following in the form a plus bi. So we have -3 plus 4i minus 2 minus 5i. We first have to distribute the negative here. So we have -3 plus 4i minus 2. Continue. Plus 5i. Good. So then we drop the parentheses. We have, that's -3 plus 4i minus 2 plus 5i. That's equal to -3 minus 2 plus 4 plus 5i, which is equal to -5 plus 9i. Okay, so that's in the desired form. Now to multiply, walk me through the multiplication in part B. Not everybody at once. What do? Use the FOIL method. So
5 plus 5i.
you have 5 plus 5i minus 3i minus 3i squared. Good, both of you. Okay, so that gives us 5. 5i minus 3i is what? Good, so plus 2i minus 3i squared. Minus 3 times what? Negative 1. Good, so that's equal to 5 plus 2i plus 3. What does that give us in the form desired? 8 plus 2i. You got it. Okay. 2i to the fourth. 2i to the fourth is equal to 2 to the fourth times I to the fourth. 2 to the fourth is 16. And then we need to figure out what I to the fourth is. Well, I squared is not negative 1. Well, I squared is negative 1. So I to the fourth is 1. Good. So you have 16 times 1, which is equal to 16. Okay, so note, so an aside, I squared is negative 1. I cubed is equal to negative 1 times I, or negative I. I to the fourth is equal to I cubed times I, which is negative I times I, or negative I squared, which is negative times negative 1, or 1. Okay? With complex numbers, I is equal to the square root of negative 1. So that's not the answer. The answer to part C, but I is equal to the square root of negative 1. That's what I is. What other questions do you have? Okay, you'll see problems similar to these in your homework. Make sure you go through those. Okay? Another definition. For the complex number z equals a plus bi, its complex conjugate is the complex number z bar, which equals a minus bi. So z times z bar, or the complex number times its complex conjugate, that's equal to a plus bi times a minus bi. Notice that is the conjugate or the opposite. The outer term and the inner term are going to do what? What's going to happen to the outer term and the inner term here? They're going to cancel out. Good. So you're going to be left with a squared plus b squared here. And it's plus because you're going to be subtracting bi squared. I squared is negative 1. So it's going to become plus b squared. Okay? So that's a complex conjugate. Now, we talk about complex conjugates because we want to talk about dividing complex numbers. So to simplify the quotient a plus bi divided by c plus di, what we have to do is multiply the numerator and the denominator by the complex conjugate of the denominator. So a plus bi divided by c plus di is the same thing as a plus bi divided by c plus di times the complex conjugate over the complex conjugate, c minus di over c minus di. Notice that we're just taking this and multiplying it by 1. Okay? Doing so, this is what we end up with. Okay? You multiply numerator times numerator, and then the denominator times the denominator. Notice that it removes your complex number from your denominator. Okay? So now we're going to evaluate the quotient and write the result in the form a plus bi. So 2 minus 3i raised to the negative 1 is the same thing as the complex number 1 over 2 minus 3i. Then what we're going to do, we're going to multiply by its complex conjugate in the form of 1, so 2 plus 3i, divided by 2 plus 3i, and that's going to be equal to 2 plus 3i, because 2 plus 3i times 1 is 2 plus 3i, divided by 4 plus 9, because we're multiplying a complex number by its complex conjugate. So we have 2 squared, which is 4, plus 3 squared, which is 9. So that leaves us with 2 plus 3i divided by 13, but that's not in the form desired, which is a plus bi. So that's the same thing as 2 over 13 plus 3 over 13i. Okay. In part B, we have negative 3 plus 5i divided by 15i. So here what we're going to multiply by is 15i over 15i. That's going to be equal to, if we multiply negative 3 plus 5i times 15i, what do we get in our numerator? Negative 45i. Go ahead. Plus 75i squared. Good. So you multiply negative 3 times 15i, you get negative 45i. Then multiply 15i by 5i, and you get plus 75i squared. Good. All of that divided by 15i times 15i. 15 times 15 is 225. So you get 225i squared. Okay? Now, I squared is what? Negative 1. Good. So we're going to do some rearranging. So this is going to be negative 75 minus 45i divided by negative 225. This is since I squared is equal to negative 1. And then this is equal to negative 75 divided by negative 225 plus negative 45i divided by negative 225, and then that simplifies to 1/3 plus 1/5 I. So if negative r is negative, then the principal square root of negative r is the square root of negative r, which equals I times the square root of r. Okay? So on the side, this is using the fact that I is equal to the square root of negative 1 here. Because that's the square root of negative 1 times the square root of r, which would give you I times the square root of r. Okay? The two square roots of negative r are I square root of r and negative I square root of r. We write I square root of b instead of the square root of b times I, so it doesn't look like we are writing the square root of bi where I is underneath the radical. Okay, so in example 4, we want to evaluate the radical expression and express the result in the form a plus bi. So notice that here we have the square root of negative 81 divided by 16. That is the same thing as the square root of negative 1 times the square root of 81 over 16. The square root of 81 is what? The square root of 16 is? So this is going to be 9 over 4 times what? Times I, right? Because the square root of negative 1 is I. Good. So that's 9/4 I. Good. Okay? Now, in example 5, what we want to do, we want to solve each equation. We want to solve each equation. Solve 3x squared plus 1 equals 0. This means that we have 3x squared equals negative 1, which means x squared is equal to negative 1/3. Then we do what to both sides? Good, take the square root, right? And then when you take the square root of both sides, you get x is equal to plus or minus the square root of negative 1/3, which would be plus or minus the square root of 1/3 I, or you can rationalize by getting the radical out of the denominator, and that would give us plus or minus square root of 3 over 3I. Either one is acceptable, either one of the last ones. Either this or this is acceptable. You need to know how to get from here to here. Do you know that? Okay, you multiply both by the square root, you multiply this by the square root of 3 over the square root of 3. Okay? All right. So, in part B, what do you need to use? To solve that equation, what do you need to use? The quadratic formula. So go ahead and take a minute and use the quadratic formula and tell me what you get. So as we said, we have A is equal to 1, B is negative 3, C is 3. So you use the quadratic formula. You have negative B plus or minus the square root of B squared minus 4AC all over 2A. What did you get?
3 plus or minus square root of -3 over 2.
So negative 3, all of that over 2. Good. And when you rewrote it, what did you get?
3 over 2 plus or minus square root of 3 over 2 times I.
Good. Very good. That's your final answer. Do you have questions how to get from the previous step to this one? You have to ask. No? Okay. All right. Have a good one. This is the end of complex numbers. You will have